Hey guys, today we're taking a look at longest consecutive sequence. So this is an interesting array question which utilizes hash sets. So given an unsorted array of integers nums, unsorted, return the length of the longest consecutive element sequence, and you must write an algorithm that runs in linear time. All right, so let's take a look at what we have. We have nums 104, 200, 132, and the output is 4 being 1, 2, 3, 4. So 100, there's no big sequence, there's no longer sequence that contains 100 because 99 doesn't exist and 101 doesn't exist. So let's take a look at this visually and let's see how this would actually look. So if we had kind of this line graph 1 2 3 4 100 and 200, then you would notice that there's one bump on each, and we just say bump is an element. Then we have 1 2 3 4, and we have 100 and 200. Then how do we know when a sequence starts? This is 0. How do we know when a sequence starts? Well, we know that a sequence is starting here, a sequence is starting here, and a possible sequence is starting here. We know that these are the starts of sequences because we don't see anything before them, right? There's no element that has a value of 0. And because there's no element that exists with a value that is less than this, because there's no element right before this, we know that this is a starter. 1 is a starter. So we'll mark this as a starter. Then 100, because 99 does not have any values, there's no counts of 99, we know that 100 is a starter. And finally, again, because 199 doesn't exist, we know that 200 is another starter. So we'll let our starters be an array of 1, 100, and 200. Now, this is where the hash set comes in, because if you think about it, how do you know if it includes the value right before? How are we going to figure that out? Well, if we're using an array, and if we're just keeping this as nums, then we would do nums.includes. But the .includes function is already linear, and we don't want to have the .includes function inside a bigger for loop, because then if we have this immediately becomes O of n squared, right? The time complexity is immediately O of n squared because we have an O of n operation inside an O of n. So for every O of n element, we're doing a dot includes, which just loops through the array again. We don't want that, which is why we want to create a set. So we want to create a set that contains all the numbers of num. So I know it's not sorted, but it doesn't really matter. So we'll take all of these numbers and we'll convert it into a set object. And a hash set is something that only takes in unique objects, which means if we were to have, let's say, 1 twice, 1 1, then it wouldn't matter. Our set would still only have 1 2 3 4 100 and 200. And even better is that the set has, in JavaScript, the set has a .has function. And if we do .has 0, then this runs in constant time. So this is much better than the .includes function, and it kind of gets rid of duplicates. So it's better for 2 reasons. So we'll create a set, and then we'll figure out, so 1, we'll create a set, and then 2, we'll figure out if set.has, that num minus 1. And if it doesn't have this, then we'll let that be a starter. Okay, so now we have our starters, and now we can just figure out how long is a sequence that starts with a specific starter. So we have our starters as 1, 100, 200, and we have our main array is 1 2 3 4 100 and 200, and this is going to be kind of very similar. So you know that a starter ends, you know that a sequence ends when you don't have the +1. So when 5 doesn't exist, when the number +1 doesn't exist, if the set doesn't have that, then that's the end of a sequence. Then you know that this sequence length is 4. And because 101 doesn't exist, you know that this sequence length is just 1. And because 201 doesn't exist, you know that this sequence length is just 1 again. And what we can do is we can set a global max variable that is going to, so we'll let max equals 4 because that's the first sequence that we stumble upon. And then we'll try and update it every time we hit a new sequence. So this new sequence ends and we see that it's 1. If 1 is greater than 4, then we'll update max, but it's not greater than 4, so we don't need to update max, which means at the very end, we loop through the entire thing in linear time, and our max is 4. And let me explain the complexity part of this a little bit more, just in case it doesn't make too much sense. So think about what's actually happening. So our time complexity is going to be this. So first thing we do is create a set by, I guess we're looping through the entire array. So that's O of n. We loop through the array and create a set. Then what do we do with the set? We figure out how many starters are on the set. We figure out, we loop through, and for each element we can do, does the set have the element -1? Does it contain element -1? And if it doesn't, then we have our array of starters. So again, that's just another O of n, but it's distinct. So this is O of n plus n thus far. And then finally, we can just do the same thing with the ending, which can kind of happen inside this second for loop. So that's again just O of n plus n, and then that's O of 2n, which simplifies down to O of n. As for our space complexity, all we're doing is creating our set object, which is going to be at max length n. So this is O of n, this is another constant space. So O of n is our time and O of n is our space, and this is even more optimized than before. All right, let's take a look at how it would function in the code. So the very first thing we're going to do is set an edge case condition. So this is if nums.length is equal to 0, then we're going to return 0. This is something that we just didn't talk about, but it's pretty intuitive. Then we're also going to let set of nums equal to new set that takes in nums as a parameter. And if you put in nums as a parameter here, then that's just going to create a set using this array of nums. That's how that works. Then we're also going to let starters equal an empty array, which will slowly start to fill up with all these starters that we have. We're going to let temp count equals 1, which will update as our local variable. And we're going to let longest count equals 1, which we're going to again update as our global variable. So the reason why 1 works here is because we've already done the edge case where it equals 0, hence the longest length, the next shortest length can only be 1. Now we're going to loop through all the keys of set of nums. And the reason we're doing, well, this is just kind of how you iterate through a set. But the key here isn't a key as in like a key value pair, it's just kind of a value. So this, but you just call them keys. You just do the dot keys function on that. Now, if set of nums doesn't have key minus 1, in other words, if there's no left neighbor, then we know that this is a starter. Then we can do starters.push key. So now we have starters as an array containing all the starters. Now starters has all our starters. Now we can iterate through starters and figure out how long each starter is. So for let starter of starters, then we can do something with each starter. And what we'll do here is we'll iterate through, we'll continue on with each starter, we'll constantly update starter while some condition is true. So let breaker equals true, and then while breaker, we'll do something, and then once we hit a condition that we want, then we'll do breaker equals false, and that's what we'll have. Then we'll break out of that loop. So while breaker, then if set of nums dot has starter plus 1, in other words, if it contains the next consecutive element, which is what we want, then we're going to increment temp count. This is our local variable. We're going to update the longest count equals math.max, whatever was in it before, and now temp count, we're going to update that with the math.max, and we're also going to update starter. So starter is going to plus equal 1, and it'll keep going until you hit the condition where it doesn't have the starter plus 1. There is no right neighbor. In other words, we've hit the end of our sequence. Then we can update temp count equals 1. Remember, we've already updated longest count from the previous iteration, so we can just do temp count again, and we can set breaker equals false, breaking us out of this while loop. And at the very end of everything, we can just return longest count, which by now should have updated. If we submit this, then this should work, and yep, that's how it's done.